In this video, we're going to be looking at finding complex roots using Demois's theorem. So we just need to recall a few things or learn a few things before we move on. Firstly, it is that when you're solving polynomial equations of degree n, we know that it will have n roots. That is, a quadratic, it's got a degree of 2, which means the highest power is 2. And so it's got 2 roots. A cubic, the highest power is 3, so it's got 3 roots. So when you're finding fifth roots of a number, so for example, if you're finding z to the power of 5 equal to 32, let's say, when you solve this, you might be tempted to say it's just 2. But what we are going to be looking at today is, no, there are 5 roots, and it's just that they're not all real. So complex numbers, or complex roots, they are equally spaced on the argand plane. So if you have 3 roots, they're going to be 360 divided by 3 apart, so they'll be 120 degrees apart. And the other thing, Demois's theorem, you should have already read about this in the notes. So if you've got r cis theta to the whole power of n, it simplifies to r to the power of n cis n theta. Now, the other thing is a complex number can be written as not just r cis theta, but also as r cis theta plus 2n pi. So all you have here is essentially multiples of 2 pi. So when you have an angle, theta, and you rotate it by a multiple of 2 pi, you're back to the same angle again, so it's the same complex number. So in degrees, of course, it's multiples of 360, so that's why we've got 360n here. At this stage, you may like to pause the video and go back over what I've just said, maybe listen to it again to help you understand better. So now we're going to be applying what we've just looked at to solve this, finding cube roots of 27 cis pi. So let's just write out the equation for this. So cube roots, so z to the power of 3 is equal to 27 cis pi. Now, because we are applying the Math theorem, we like to have the right-hand side in polar form, but this is already in polar form, so it makes it easier for us. So the other thing is, let's write this in a more general form. So it's 27 cis pi plus 2 pi n, because we are in radian mode. So that's the equation we are trying to solve. So we are going to take the cube root of both sides. Okay, at this stage, I'm going to take cube root of left-hand side. That gives me z. And here, we'll just rewrite it like this. So remember, Demois's theorem says z to the power of n is r to the n cis n theta if z is n cis theta. Okay, so here, if we just apply the same thing, our n in this situation is a third. So just applying Demois's theorem, you've got 27 to the power of a third cis pi plus 2 pi n times a third, which can be just written like this. Now this is our general solution. So remember, there are 3 roots for this equation, so we're going to find all 3 of them, and n is just an integer that we're going to substitute in, so it can be negative or positive, and 0 as well. So let's start with n equal to 0. So 27 to the power of a third is 3, so we'll write that in. So 3 cis pi plus 2 pi times 0 over 3. Now that simplifies to 3 cis pi over 3. So this is our first solution. So we'll write that as Z1. Okay, so when n equals 1, we can have Z2. So 3 cis pi plus 2 pi times 1 over 3, which gives us 3 cis 3 pi over 3, which is just pi. Okay, now you can substitute n equals 2, or you can substitute n equals -1. So I'm going to do both and show you how they give you the same answer. So let's start with n equals -1. So that works out to be 3 cis negative pi over 3. Now, let's have a look at substituting n equals 2. So that gives me 3 cis pi plus 2 pi times 2 over 3, which is 5. So that's 3 cis 5 pi over 3. Now, I just want you to realize that 5 pi over 3, when you write it in principal argument form, it will be the same as negative pi over 3. And let's just have a look at that. So here you have 5 pi over 3 is pi and 2/3. So it's about here somewhere. Okay, so in principal argument form, we want the angle to be between negative pi and positive pi. So we are looking at this angle here. So we know it is in clockwise direction, so it's going to be negative. Okay, so all we are going to be doing is, so you can see it is 2 pi, take away 5 pi over 3, but because it is negative, I'm just going to put a negative there. Or you could just do 5 pi over 3, take away 2 pi. And either way, you will get negative pi over 3. So you can see that when you just keep substituting different n values, you're going to get the same roots again and again.